So good afternoon, everyone. I'm Alex. This is my colleague, Olex. We're both engineers here on the graphical platform team at Intuit. And today we're going to be talking about how we stopped reviewing schemas, or at least how we stopped reviewing them the way we used to. We're going to be sharing the journey of how we automated governance to make our developers faster and how you might apply similar principles. So we'll structure our talk into 4 parts. First, we'll set the stage by showing you why the traditional manual review process completely breaks at Intuit scale. Then we'll dive deeper into the smart tools we created to build a better governance model. Then we'll share the results, the real quantifiable impact this had on our developer velocity. And finally, we'll end it with our key lessons and a glimpse into the future. So let's start. Why manual reviews break at scale? I'm sure many of you are familiar with this problem. To understand our pain, let's first look at our scale. We can visualize it as a GraphQL galaxy, and at the very heart of this galaxy, our developers are kind of the gravitational center, the force that holds everything together and pulls innovation forward. Orbiting them, we have 90-plus subgraphs in production, creating a system of tens of thousands of fields and types that we have at Intuit. And a key metric here is actually the 50,000 schema validations done a month. So this is what our automation has led us to. Basically, it's able to capture 50,000 different schema quality reviews, all automated. Next, we have the schema enters the review step, and here's where it gets into a cycle of feedback and revisions. And then finally, once it's compliant, it's approved, and it's allowed to be published to the supergraph. Now, on the surface, this looks like a standard linear process, but for a long time, one of these steps was a black hole for our developer productivity. And that's this one. The review schema. This single box represents what was a completely manual, inconsistent, and slow bottleneck that held up our developers for days and sometimes weeks. And this is a problem we really had to solve. The impact of our developer was immediate. Long review times had them stuck waiting in approval queues for days and sometimes weeks. Meanwhile, our expert reviewers were completely burned out. And by expert reviewers, I mean manual, human reviewers that had to manually approve each subgraph onboarding. They were context switching all day, leading to inconsistent feedback. Depending on the person that had to review, they might have different domain knowledge. They could give inconsistent feedback even if they review the same schema on different days. And we realized that some of the most important complex best practice just couldn't be captured by the traditional and basic linter. It became clear that this manual process couldn't scale with our teams and was fundamentally broken. Next, I'll hand it off to my colleague Olex to show some smart tools we've created.
So now more like for tangible things. Actually, I wanted to talk about our current tool set. So the first thing we have, like this traditional linter. You probably everyone knows like the GraphOS linter, right? But we have our custom solution. We have our Intuit defined guidelines and rules, and we switch to this custom linter that we maintaining, and it validates against our custom rules. The second tool, more interesting, that's an AI linter. We call it this way, to validate more complex rules. To give you more understanding what is traditional linter can capture and what the AI linter, let's say traditional linter can capture the errors you don't have field in the camel case, right? You don't have the namespace yet with the underscore before. And we use the AI-powered linter to capture things like that field has a clear intent, that your lists, they're implementing the pagination, so as the best practices, right? To talk about technical details, just a bit. So we had quite a lot prompt engineering to construct this contextual queries, and we're passing it to the Gen AI LLM for execution. So as I said, getting the context from our guidelines. So we have the examples, what is bad, what is wrong, what is bad, what is good. And based on that, we check on these rules. And the third thing is AI semantic collision detection. So this is more about like your schemas, right? Your types, your fields, they must have some description. And but this description can can be duplicated, right? You have, I don't know, like the ID fields that you can just like write the description. This is ID field, right? So you will have the same description for multiple types, multiple entities, right? So this is about checking all these possible collisions. How it benefits us, the same as the second tool. We can have more clear intent, defining the schemas. We can have more clear intent defining the fields. And this helps, for like all the hype stuff. We can add, like create the tools, right? The MCP tools, or any like AI discovery of API, or just a discovery of API, right? We have all our schema. You have seen a scale, so it's very crucial for us to have the clear intent, the self-explanatory fields and types. For the like technical details, we build like the cosine similarity, and we check it against types, fields and descriptions within subgraph and on the supergraph level as well. I will show you later on the demo how it looks like. So now, as Alex mentioned, we have like two key flows. The first one, when the initial onboarding happens, and all the so this is like basically CI/CD flow, right? The initial onboarding and all the schema change, they also involve the CI/CD flow. So here, you can see that like the push event is basically when you're pushing something, your schema changes to the Git. Then we build the schema. This is basically a composition of your subgraph schema, all the common types we have. By the way, we'll have later in this room, we'll have another members of our team talking about the common schemas. So feel free to attend this as well. We're building the final schema, and we run these tools that we already talked with you about. One more small thing, we have also exceptions. So we have exceptions global and based on the subgraph. So the global one is more about like the common types. Maybe we don't need to check the common types, so we like automatically add them to global exceptions. And each team, subgraph team, can have exceptions on the subgraph level. So it can be on the field level or for some specific rule. So not every case like fits all the teams, right? Maybe for some schema they don't need exception, but they have some some collision, and some other team has collision and they need to have an exception for some field. So obviously, if tools return errors, the output returns errors, we fail pipeline. If not, we publish the schema, and they're ready to use it. So now time for the quick demo. This is a demo about like the initial onboarding. So this is our dev portal when you create the service through the paved road. So this is like, imagine this is subgraph service. We have the start schema composition button, which basically initiates the onboarding request and creates the GitHub issue, where like all the description about the project, or like all the checklists you need to go through to make it like prod ready. And you see we post linter results, no errors, and AI linter result. We see 4 errors here. And that's one of the rules that you need add pagination for your list type, because you might have any like performance issues, if you don't add pagination or list is too big. So this is kind of things that traditional linter cannot capture. It has few levels, of the severity, errors, warnings, and info. And basically, you need to, like our team need to fix all the errors, to successfully publish the schema. Yeah, and the third tool is the collision check. Yeah, that we talked before. That checks the collision, or like semantic check. Yeah, and going back, yeah, we have the second flow. This is like developer, we call it developer flow, but it's mainly when you have ongoing schema changes, right? So for this, we shifted left. So instead, teams waiting for their CI/CD pipeline like to fail, right? Because they, I don't know, they didn't comply with the guideline. It takes time. So we improved this, and we introduced the IDE plugin. And IDE plugin has two items, right? Traditional linter that we have seen before, and this collision detection. We have plans to add AI linter as well, but now, yeah, now it's only these tools. So yeah, you do the schema change. You can run like both checks, right? And yeah, get the immediate feedback what you need to fix. Yeah, so this is a quick demo of this IDE plugin. Yeah, the first page, you need to specify where is your like schema spec file located, right? Which like identifies which schema files is used by your project. And yeah, I have the dummy data just to show you the functionality. Let's run linter. Yeah, as you can see, yeah, we have the few severities, as I mentioned. You need to basically, yeah, to fix all the errors. You can filter like the severity level, the lines, yeah, like descending, ascending. Yeah, that's the boring stuff. Yeah, sorry. We need to wait until I will play around, and we will go to fixing errors. Yeah, that's an awkward silence. Yeah, so the errors. This is a simple error that I mentioned before as well. This is like you need to specify your fields as a camel case. We have a link, yeah, to our guideline. So if you don't know how to fix, you can click like how to fix, yeah, and it basically leads you to our guideline page. Yeah, let's fix it to use like the camel case and run linter again. So both fields, they have the same issue. Yeah, you see, we don't have any more errors. So you're good to go to publish your publish your commit, yeah, and run the pipeline. The second thing I want to show you the collision detection. So you basically the second tab, and yeah, you choose the supergraph. You choose the environment since we have the multiple variants. Yeah, you can run the check against supergraph and multiple variants of it. And yeah, in this demo, I want to focus on the type collision. So yeah, as you see, we have type collision and field collision. And yeah, this domain refined enrichment field, domain refined enrichment type, it has the collision within the same subgraph with the transaction enrichment field. So basically, yeah, as I mentioned, like the problem is mostly in the description. So yeah, let's fix it, add more details to description just to make sure it is unique, right? Because our intent to make it self-explanatory with a clear intent. So yeah, after adding like more details, fixing the description, we should not see the type collisions. Yeah, we're good. Yeah, there's still 361 field collision detection, but yeah, that's what about the types. Yeah, results. I will want to share like the results we have. So yeah, you see like 90+ days. That's crazy. This was a number when we didn't have any like automation in the process. So teams manually issue the request to onboard the supergraph, to review the schema, to be approved. And yeah, that's a huge number. In August 2023, we launched the automated self-serve. So this is like a dev portal that you've seen. So you can initiate onboarding by clicking one button. In May 2024, we integrated the schema insights. So that's actually the comment to the issue, GitHub issue you've seen. Basically, at this time, we just had a linter, traditional linter. So the API steward, it's the person who actually reviews your schema and approves the onboarding. They can use these insights, to check if we comply with if team complies with the linter, and point out to any problems, and ask them to fix. In March 2025, we released this IDE plugin that I showed the demo about. And in August 2025, we released this AI schema check, this AI linter. Now we have less than 10 days to onboard. That's a good result, like 90 plus. Maybe it was bigger, but 90 plus looks better. The second thing, this is like diagram per each subgraph. So I chose like the four, I would say like the biggest one. So this is the number of linter errors per like subgraph. And you've seen we managed to have less errors per subgraph. So we have a cleaner schema, and our teams are using the plugin to do this. So we increase their velocity, that don't wait for the deployments, that don't spend time waiting on it. Great results. I'm passing word back to Alex. Thank you.
So that's our story so far. And we wanted to share some important lessons that we learned along the way and give you a peek of where we're headed next. So the first lesson we learned is, shifting left is not enough. But what does it mean to shift left? Shifting left just means moving left from where your current state is. It doesn't necessarily mean you have to shift all the way left. But if we just look at the rightmost extreme, it's where the approval happens, right? When you publish a subgraph, that's like your rightmost that you can go to, right? And then we actually shifted left twice, we shared. So we shifted left once in the CI/CD process where we added the security guardrails. We shifted left one more time into the IDE to meet the plugins, where the developers interact with the plugins. But simply putting the linter in the IDE wasn't a silver bullet. Our early feedback showed that just flagging an error without providing clear, actionable context is more noise than help. We learned we had to invest heavily in crafting high-quality error messages, linking to the direct documentation, like Olex has shared, and using AI to explain why something is a problem. And the lessons we learned, that the quality of the feedback is more important sometimes than the speed of the delivery, which is pretty apparent with all the AI, MCP, and everything going on. People want to have that speed for delivery, but you have to focus on the quality as well. So next, a rule severity is entirely dependent on the user's persona. So if you recall in the demonstration, we have different severity categories, error, warning, and info level, and there's no universal standard for this. But when we first started, we did have what we thought was this error, warning, and info level. But what an API reviewer might see as an issue, an author might consider as a minor issue. So the lesson here is that governance tools need to be somewhat persona aware in their configuration, and the same rules might need to be a non-blocking suggestion for a developer, but a hard block for a final governance review. And that's something we're still working on perfecting. We have the exception, the global exception, and subgraph level exception that Olex has shared before. But this is something we're still iterating and perfecting on. And lastly, your exception logs are your best AI roadmap. So a surprisingly rich source of AI roadmap came from studying the limits of our rule-based system. This insight came from basically two directions: by analyzing why developers requested these exceptions for their nuanced use cases, but just as importantly, we proactively identified problems that we couldn't solve deterministically currently. So every time we hit a wall with a static rule or a developer had a use case that broke our assumptions, it became a kind of like a perfect signpost. Each of these exceptions pointed us directly to where AI ability to understand context and nuances can help us deliver the most significant impact. So we're incredibly proud of what we built, but we're just getting started. Our roadmap is focused on deeper AI integration. So we have things we're exploring like automated approvals for low-risk changes and supergraph onboarding requests that we have high confidence in based on the reports on the GitHub issues like you saw. This doesn't mean we're taking humans totally out of the loop. We still need some manual human intervention currently for the final approval. We're also working on AI-powered fix-it suggestions that don't just find problems, but suggest the code to fix them. So you saw we have spent a lot of time crafting these quality guidelines and have automated them so that this AI linter, traditional linter, these collisions check, build the foundation of our quality supergraph. And the next step is to take all those valid problems and issues that are detected and feed them back into the AI to make suggestions for us on how to auto-fix this. And lastly, we're trying to enable AI-powered API discovery, allowing developers to use natural language to find exactly what they want across their graph. And you guys kind of got a peek of this during the keynote for the MCP when they did the introspection, created operations from the agent, agentic AI. And that's something we're trying to do next now that we have a foundation to grow upon. So our ultimate vision is twofold, the self-governing ecosystem, one that automatically enforces its own rules with the guardrails that we showed. And we're also building towards a self-healing one where the system doesn't just find the problems, but uses AI to actively fix them. Yep, and thank you for your time. That's it.